Hello, everyone.
Hello. Right, yes.
Happy GCAP.
Happy GCAP.
Always good to be here at MIG-W.
Yes. Cool. All right. Hi. Welcome to A Producer's Delight, formerly Provable Narrative. We're your good friends, John.
And I'm Tim.
That's right, yes. I'm Narrative Technologies lead at Yarnspinner.
And I'm development lead at Yarnspinner.
Yep. We are from Hobart. It's great, and you should be there. Yeah.
Come visit.
Yeah, please come visit. It's actually really nice. It looks at this all the time. It doesn't. So we work on Yarnspinner. Yarnspinner is a tool for writing dialogue trees. Raise your hands if you've heard of it. Hey, that's really great to see. This talk is based on our work on that internally and also for some client projects. We originally built Yarnspinner as we were working on a game called Night in the Woods, and it has expanded since then. Yarnspinner is in use by a lot of games, both by us and by others. This is not a Yarnspinner talk, this is a Yarnspinner adjacent talk. So this is not really a mission statement, but it is just something that we think is true. Computers should make the boring parts of game development a lot more not more bearable. I almost said variable. No, it's variable enough. So this kind of like underlines a lot of what we do at Yarnspinner and also why we do stuff at Yarnspinner the way we do it. So like I said, this is not about it, but we think that this is a lens we can apply to an approach that works for any dialogue approach and any dialogue system.
Okay, so kind of the goal of why I think most people get into narrative in games is you want to make games with interesting and complex narrative. You have a story you want to tell and you want to be able to do it in some way. Now, implicit in this, if I can... There we go, spacebar. I know how to use a machine. Implicit in this there's sort of two questions that this goal raises. And the first of this is, how can we be sure that every line is reachable? Hopefully that's not too controversial. And also, how can we be sure that every quest is completable? Now, not necessarily in one run-through. Likewise with the lines, you might not want to see every line in through every run-through. But hopefully these sort of make sense. And these make sense because unreachable content is wasted time and money. You've had to develop it. You've had to work on it, you've had to make it happy and enjoyable for the players to experience, and then they never get to experience. You've literally wasted time and money. And the thing is, it's really hard to know if something's unreachable until eventually you learn it's unreachable, so it gets as much production value put on it as the things that are reachable. So not only is it wasted time and money, it's wasted time and money that you only later learn is wasted time and money, which is much more frustrating. And it's also just sad because, well, you know, you made something and people didn't get to experience it. That sucks.
So we're going to be taking a look at a small demo game that we made to kind of act as the lens for this. So if you're following along at home, whether you're watching this on a recording or if you're in the audience, you can scan this QR code, it'll take you to that link, or you can type in that link. And this is a really, really simple text adventure. So, great. And I'm just going to, and... Hey, cool, that works. Cool. Yeah, turns out Mac users, Command F1 is switched between mirror and not. Saves me so much time. Okay, so this is a really, really simple little like text-based adventure game. We've been playing a lot of Baldur's Gate 3. Raise your hand if you've ever been playing Baldur's Gate 3. Nearly everyone in the room. So there's a little bit of overlap here. And so this is a fairly generic fantasy little universe where we go through, we can talk to characters, and we learn that the key thing that we got to deal with in this story is there is an evil prince who must be defeated. Standard high fantasy trope. And the other key thing that I want to draw your attention to is the fact that at the top right-hand corner of the screen, you'll see that there's a journal. Again, classic RPG thing, keeping track of what you got to do and how you got to do it. All right, so this is the basis for all of that. Now, rather than make you read through all this text, because we're going to be taking a look at this, I'm actually just going to hop into the source code and go into lightweight mode. Now it will show a much simpler version. There we go. All right.
It's worth also showing off the quest structure.
Of course it is, yes. So the other thing I'm going to show you as well is the demo game also has an underlying quest structure which is visible here. This is a tool that, again, we'll come back to. All of these grey boxes here are the various quests inside the game. So, 1, 2, 3, 4, 5. And the key one is the one at the right-hand side here, the one about that evil prince who must be defeated. And you can see there's a few different things you got to do in this game to reach the end of the game. So this is basically how we sketched out the flow, and you've just seen the game. Okay, cool. This is the foundation for what we're looking at next. All right. So, no. There we go.
Don't ever do live demos.
No. So, yeah, this whole talk is just tempting the demo gods constantly. So get ready for that. So, with this in mind, how can we answer these two questions? Can everything be seen in the game? And can every quest be completed in this game? Now, the traditional approach to making games, and in fact, honestly, the only really good one, is test. You got to test the game. You got to play through the game a lot, and then once you've played through the game a lot, you got to play through the game a lot more. So, to that end, let's do a real quick run through of the game. We're going to play through the golden path of the game as fast as I can. So, let's go in here. Whoops. Okay, so.
Step 1 is we're going to talk to the mayor. That is our first step.
Great, and we're going to talk to the mayor, and now we know about the evil prince.
Once we've learned about the evil prince, our golden path is we're going to return the heir to the family.
All right, cool. So we go to the king's robe, we find the heir, we talk to her, and we say, go home. Great,
yep,
cool.
Sweet, love it. We're now going to return to the noble's house, because they're so happy to return their daughter, they're going to teach us how to defeat the evil prince.
Great. So we talk to the noble, great, yep, great, fantastic, done.
Love it.
All right.
Now we're going to need some stuff. So first of all, we're going to have to go find the Witch of Knives and kill her.
Great, we're going to go to the king's robe, we're going to go to the forest, we're going to go into the forest, we're going to go to here, and then slay the witch. Great, done, and we pick
Easy.
up her blade. Great, done.
So that's the first of two things we need. Now we're going to have to go back town, talk to the blacksmith, because
Okay,
the blacksmith's
cool.
going to tell us how to get the magic armor.
Now we go to the blacksmith, and we talk to here, talk to the blacksmith, okay, ask about the armor.
Everyone's
yep,
following
great.
along, right? Yeah,
Yep, good, cool, yeah, nice, all right, talk to the blacksmith, but we need blueprints. Okay, cool.
Where do we get the blueprints?
We go to the Scholar's Tower.
Scholar's Tower.
We go here, and we find the papers, and we find the blueprints. Fantastic, great, cool.
Now we need mithril. All right,
Great,
back
cool.
to town. Let's
All
go
right,
talk to the miner.
Okay, we go here, we go to the mountain, because that's where you find stuff. We talk to here, and we find the miner, we talk to the miner, and we take the mithril.
Not the cursed gold.
Not the cursed gold. All right, cool.
Go back to the blacksmith.
Okay, we go to town square, we go to here, we go to the blacksmith, we go to here, and we say, hey, make me some armor. Great, craft the armor, great, cool, nice. Now we go, and we're done, I think we've got everything we need.
We're good?
Yep, cool, we learned everything we need.
Let's go
to
Biffo
town square.
Frederick.
Fantastic, we're going to go to the king's robe, we're going to go to the castle, and we attack the evil prince. Hooray! Right. Okay. All right. I wasn't timing that, but how long was that?
I wasn't timing it either. That was a minute or two, right?
Yeah,
about a minute,
yeah. All right, cool. Now do it again 1,000 times. No, but you kind of have to. And so in a second, as we'll see. Yeah. Cool. Oh, come on. Great. Okay. That wasn't too bad. That was kind of fun and kind of funny the first time. In case you missed any of those steps, here's what we just did. This is one path from the start of the game to an end point in the game, where we do all these things and we get everything we need, and then finally, congratulations, we done it.
We did it.
But like I said, this is only one possible path through the game. We want to test the entire game. There's lots more content in here that we didn't see. So we want to make sure that we can see all of it. So how many times will we need to test through?
Well, let's start reasonable. Let's say we're just going to make the player or the testing do 10 steps through the story then. How many paths is that?
So in terms of total possible paths, 31,000.
All right, what if we do 11 though?
Oh, that's easy. That's only another 60,000 more.
All right, but we needed 14 steps to do the whole thing. So let's say 20 because the player's going to spiral around a little bit. You know, how many is that?
Well, I'm sorry to tell you, Tim, that we'll be actually looking at 1.7 billion.
Huh.
Yeah.
That might be too many.
That I think, yeah. Like, because we're going to ship by Christmas. So...
Okay, so I think it's time to add another implicit goal to our internal goals here, which is how do we do this without burning out the poor QA staff? Because, like, I don't know if they can do 1.69 billion run-throughs of the game. Maybe they can. They're pretty good.
I don't know.
But,
if we really made them crunch.
If we really made them crunch. We don't want to do that. We don't want to melt them into goo just to do the thing. So if doing it manually is no good, how do we fix it? All right, alternate solution time. We're going to simplify everything so it's easy to test. We're just going to cut content, we're going to thin things down, we're going to make it independent. We're going to reduce the complexity of the quests. Now each piece is independent. They don't interconnect as much, so we don't have as many different exponential growth of the checking. We can just test each piece independently. Once it's signed off, it's good. Unfortunately, this does have a side effect. The real side effect this has is it impacts the stories we want to tell. We now can only tell independent stories. And we're going to create a world that feels disconnected. I don't know about anyone else, but you'll often be playing a game and you got all these like really cool twisted stories together. Then you get to the next area and you can tell they're just like, we don't have time to make that again. Every quest is siloed.
You might have noticed, like, you go to a town and the best you'll get is one more bark. Did you hear about what happened the next town over? And then nothing else after that.
Yeah, this is unavoidable. The simpler your quest and story structures become, the less narratively complex they become. So that's the trade-off you have to make. It also actually has another issue that is sort of like a little bit more devious to work out, which is you've actually moved handling the complexity from test time to writing time. Now, what this is doing is it's pushing the load off one team, QA, onto another team, narrative. And this raises the question, is that better? Now, I actually unironically think it is better. I genuinely do, because the load that you're putting on your team is lesser at development time than it is at test time. So it's much easier to find and fix these bugs at this point. But it still has another issue. What if you want to change something that impacts a previously tested thing? Suddenly, regression. Your bugs are back, you've got these issues that you didn't even realize were there. So, surprise, complexity's back. And in fact, you never really got rid of complexity, you just shifted how it was understood by the team.
So, okay, so we can't test every path, but we also can't really properly just reduce number of paths. What can we do? Well, one solution, in fact, what we propose is the best solution, is you make the computer do it. So we could make the computer run through all 1.7 billion possible paths and find out if we reach the right content. Unfortunately, 1.7 times, about a second to complete is still 1.7 billion seconds, and that's a couple of decades. That's no good either. What we should do instead is make the computer do it smart. Now, there is a range of sophistication that we can apply to this. The least sophisticated is we test everything manually. We could identify and test specific important parts, for example, like the critical path, the golden path, certain less important stuff we want to make sure is seen. We implement stochastic methods to increase our test coverage. But the big brain play is you solve for every possible universe that the game could experience at the same time, and you do it in a minute. Now, the key realization that we had while developing this system is that every single dialogue tree can be expressed as a collection of logical equations. And when you have a collection of logical equations, you can treat those as a system of constraints. And when you have a system of constraints, you can solve those constraints mathematically using automated solvers. So, solvers. It's not a very common term in game dev right now. I know that there are some games out there that do use them.
Who's actually heard of a solver?
Yeah, a few people. Yeah, but also not so many that I'm now worried about the premise of our talk. What is a solver? Well, a solver is software that can tell you if a collection of constraints are valid, and if they are valid, how are they valid?
So, it's sort of like, as with a lot of different things, I think these become more obvious if we walk through an example. So how do they work? We're going to actually walk through a little example of a solver solving a problem and use it to validate some constraints. This, if you're interested, is based on the Davis-Putnam-Lodgeman-Loveland algorithm, which was published in 1961. So it's got a little bit of heritage to it. So let's imagine we've got this following imaginary world of a Boolean problem. We've got circle, or, square, and triangle. So that's our Boolean expression. That is our constraint. We're actually going to add one more step to it, or else this would be way too easy to solve and it would be a very boring demo. So we're also going to add another constraint of not circle. Now, these are our theorems that we're going to try and validate against. So what we do now is we start by picking a variable, and we're just going to pick circle arbitrarily. It doesn't actually matter which one you want. We're going to go with circle. And the question is, what happens if circle is true? We're just going to explore the space step by step. Okay, so circle is true. All right, does that work? Well, for the first constraint, yeah, it works perfectly fine. Okay, cool. So with that done, let's start exploring this step here. So circle is currently true. Well, hang on. But now we've got another constraint, not circle. Well, but that can't be true because not true is false. We're not allowed to have false. That means it has to be false, right? But we just said it's true. Okay, so circle cannot be true. We've actually just proven it. We've exhaustively searched every possibility. Given these constraints, circle can never be true. Which means we need to explore what happens if circle is false. We walk back up the tree and start the other branch. So we can't evaluate the whole thing now. We're actually going to have to keep going. So we're going to have to check, what about square? What happens with square? Well, we'll follow the same pattern. Can square be true? Well, hang on, if we look at this here, it's an and, so yep, that's allowed. That means we now need to check the next step. What about triangle? So again, we're just sticking with trues here. Can it be true? True and true is perfectly allowed. Ergo, we have now found a valid solution for our constraints. So we've found the world where circle is false, square and triangle are both true. And if you sort of look at it, that's hopefully obvious enough to you. This is the only possible one. And in fact, the way solvers work, once they find any solution, they stop. And then you can be like, no, buddy, just keep going. And in this case, there is no other universe where that's possible, so we'll actually just exhaust the whole tree and be like, this is it. It can only be these values. And the trick here is you need to start realizing, hang on, these represent things in the story. Even though they're abstract booleans, they represent things in the story. So circle is the dragon is dead. Square is the witch is dead. Triangle is the dragon is befriended. And then that one is the dragon is dead, or you slew the witch and befriended the dragon, and the dragon is not dead. So the final step in all this is you got to sort of like remember to map it back to the story world, because by itself it's like an interesting quirk of maths, but like if it's not connected to anything, it's just an interesting quirk of maths, and no one cares about that. Now, well, maths people do. This is a very brute force heavy approach I just showed you, and solvers are much smarter than this. In fact, I'm sure if you're looking at that, you're like, well, hang on, I can solve this instantly. It has to be this, because you could simplify it very quickly. And solvers do actually have a whole bunch of tricks and approaches they actually use. Working out which variables to start with, how to start mutating them, so on and so forth, is a lot of like secret sauce of different solvers and different approaches. Everyone has their own strengths to these. But failing any smarter approach, this is actually what every solver will fall back on. If worse comes to worse, we're going to brute force the entire thing. And it's proven it will tell you the answer, tell you there isn't an answer, or run out of time in the universe.
So a thing that often comes up whenever we describe this thing to people is they ask, well, is this AI? Is this the same thing as AI? And the answer is no, not really, not how we use the word AI these days. This came out of an area of research that in the domain of AI research, but it isn't what we now call AI, which is, it is not a large language model. In that solvers are old, proven tech. That's a little math pun there for people in the audience, they're proven, haha. And the basis of this was actually proven in 1971 by Cook, and then they're actually in use for 20 years before it was further proven that they were valid for all software problems as well. And as a useless piece of computer science history for you, the Boolean satisfiability theorem, which is the thing that they actually are solving, was the first NP-complete proven theorem. So that's a fun fact you can use at parties. I will be using that at Megadev. Yeah. So they picked up in use recently because simply computer hardware got better. Until around 2000s, computers didn't really have enough RAM for solvers to be hugely viable for real-world practical tasks, but now they do. And they've now been in use behind the scenes for decades. Every modern language compiler is using a solver as part of its code flow analysis, its equivalent graph generation, and its code flow and optimization, its code optimization rather. So they're in use, they're solid, they work, they're proven. Now, the follow-up question we often get is, sure, but can I just take the script and chuck it into ChatGPT, and ChatGPT can give me an answer? And it could give you an answer, yep. However, there are some key differences between solvers and language models. For example, solvers can't lie to you. Solvers don't need to be spoken to like they're idiots. Solvers can actually explain their results. Solvers can exhaustively explore the domain. One point that we will give to language models is a solver cannot write you a bad poem about onions.
Nothing's perfect.
But more seriously, we actually took the same problem that we're going to explore in this talk, and we handed it to a language model and asked it the same questions as rephrased into natural language. So I gave this to Gemini Pro 1.5, which is the best language model that I have access to right now, and I asked it basically, hey, can you reach the end of the game? And it gave me an incomplete answer in that it says yes, because you need the magic armor, and skipping over the fact that you also need the ancient blade, so it missed that. So I gave it a leading question, well, what about the ancient blade? Do you need that? And it said, nah.
In fact, it doubled down on nah.
Yeah. And then when I asked it, okay, well, are there other ways that you could complete the game? It actually made shit up and said, well, you could try talking the villain into being not being evil. Okay, I mean, there's no diplomacy in our game, though, only violence. So, yeah. What I'm saying here is that an LLM makes shit up all the time. A solver cannot do that. There's no way for it to hallucinate facts.
So, all right, how do we actually start using a solver in a narrative game? How would you actually start adapting this, what is currently quite theoretical concept, into something practical you do? So the very first step is you need to convert your story into a form that the computer can understand. And this is actually easier than it might seem. So let's say you've got the following story here. This is like a very simplified script of Yarn Spinner, where it's essentially you start at the start, you're going to have to either kill or seduce the dragon, and then that's how you deal with the dragon. You then leave.
I love it when a game respects my time.
Exactly, yeah. So we only have 2 paths through the story, realistically, and you can work these out automatically. You can work these out very trivially because we call them dialogue trees for a reason. They've got this structure inherent to them. So working that out is actually pretty easy. We've got start, and then you will always either kill or seduce, and then you reach the end again. This actually gives us 4 different worlds to consider, is the way to think of it. So the first one is the world where the story begins. The world where we kill the dragon, the world where we seduce the dragon, or the world where we just reach the end. And you can work out the constraints for these worlds pretty automatically just through reading the branches in the path. So, for example, the story starts with the dragon not seduced and not killed. And then the story ends with you having either seduced and not killed, or having killed and not seduced the dragon. So these are the sort of different worlds which you can explore. Then the next step is you need to set up the constraints for what you actually want to test. So this is the bit where it can no longer be done automatically. You, as the person, need to go, okay, this is what I care about. So, for example, if you want to ask the solver, I must reach the last line of dialogue, you'll have to give it a constraint like this. You could actually simplify this very easily into seduced is not killed. So this is I don't really care, I just need to make sure I can get to the end somehow. Or perhaps you're like, the player can't both seduce and kill the dragon, which means this has to be the case. So these are the sort of constraints you have to start thinking of. You have to generally start thinking a little bit backwards, but you will get the right answer. And then finally, you might have something like, under what circumstances can we kill the dragon? So we need to reach the end, and the dragon needs to be dead. In which case, we have to have that whole we've reached the end constraint, we've added an additional constraint called killed, and we honestly don't care about seduced. In this case, seduce will be false, but it's entirely possible that you've written a story where you are allowed to seduce and kill the dragon, but you only care about killing the dragon. And then finally, once you've got this series of constraints, you just chuck it into the solver and go, hey, is this possible? And arguably more important, how is it possible? So I think this is actually sort of the real trick to them. You already know it's going to be possible. You wrote the story. It's very unlikely you're writing a lot of stories that can't be solved. You're going to have a couple because people make mistakes. But most of the stuff you're writing is going to work the way you expect it to work, primarily. But you're always going to make small little mistakes, and there's going to be unexpected stuff. So what the solver can do is it can tell you, yeah, I worked out how you can kill the dragon. Here's the flow. Oh, by the way, I also worked out how to seduce it just accidentally along the way. And you're like, hang on, that's not right. I'm going to have to go fix that.
So we've made a tool called Story Solver that is kind of our take on using a solver in narrative. And so I'd like to show what that looks like. So, Bip. Cool.
Try the demo again.
Tempt the demo gods. All right, cool. So Story Solver is in fact this tool here that I showed you at the start of the presentation. Story Solver is the tool for designing the quests, and you'll notice that it's made up of lots of little nodes that are all connected together, and those nodes have little conditions between them. So you can see, for example, we have the dragon quest starts at the start and it ends at one of 2 different ways. That critical path that I showed you earlier is it starts at the start, ends here, and has stuff you do in between.
Is that visible for the people at the back?
Yeah. Can you read the text here? Is that all right at the back?
Okay. We can probably zoom a little bit more.
Zoom a little bit more like that, yeah. Unfortunately, it's a non-trivial quest, so we can't really, can't show all on screen at the same time, unfortunately. All right, so we can, for example, in this here, this is not the game, this is just the quest editor. We can go into our test mode here, and we can say, all right, let's check out the dragon quest. So we'll say that we know about the dragon. So we'll say that we know about the dragon, which means we're now in the step deal with the dragon. Okay, cool, and we've got the task slay dragon. All right, cool. Now we'll set dragon dead to be on, and hooray, dragon dead is here, and it computes what our journal state would be under these circumstances. All right, very nice, very cool, but not really any different to what we're actually doing in the game. The cool thing about using Story Solver, though, is that we can take this and we'll do it in reverse. I can tell the solver, I want the current state to be that the dragon quest is in dragon dead. So I'll go dragon dead, and it figured out in reverse that we must know about the dragon and that we must know that the dragon is dead, purely by saying that we're in this state. And that also applies to any other part of the game's quests. If I go to our critical path, and we say, whoops, and we go to, no. What have I done? I think I have, click and drag. Yay, cool, it's back. Yep. If we say, I want to be at the end of the game, well then I'll take our evil prince quest and say, the evil prince is defeated. So, yep, I'll say that. And what that just did is it solved the entire game.
We actually zoom out further.
Yep. Here, it has said, you actually completed multiple quests. You are at the end of the game, and to do that, you need to have befriended the dragon, because in order to defeat the prince, you must know how to defeat the prince, and you can get that in one of two different ways. We didn't do any of this quest here, because it isn't actually needed. We have completed this quest here end to end. We have completed one of the two endings of this quest here, and of course, as I mentioned, we have reached the end of the game. All right, well that's really cool, and one nice thing about this as well is, as Tim mentioned, you can ask a solver for the state. So not only are we saying, is it possible, we can ask it, how is it possible? So if I click download this game state, then I have downloaded a save game, and now if I just restart our game here, I can now paste in that save game, boop, now we're at the end of the game. And now we can talk to the mayor, and the mayor says, thank you for defeating the evil prince. So all I had to do was say, I want to be at the end of the game, and it figured everything else for us. It has said, yep, okay, you crafted the magic armor, you slew the witch, you defeated the prince, and also there's nothing here about the heir because we wasn't needed. Okay, in addition to being able to solve for the end state of the game, solving for the happy part of it, a solver can also detect issues as well and bugs. So we've already told it that the evil prince is defeated. That's great, and it found a solution in which, zoom out, and zoom back in again, in which we learned how to defeat the prince because we befriended the dragon. But there's another possible end state for this. We could say that the dragon is dead. Okay, so we'll go dragon dead. Dragon is dead now. Okay, that's still possible because the other way you can learn how to defeat the evil prince is by returning the lost heir to her family, and then the heir, and then the family tells you how to defeat the prince. Okay, what if we further constrain it? What if we say, okay, I don't want to be in that state. I want to say we actually help the heir elope. And the solver goes, okay, that's impossible. I've dropped the thing. That's impossible. You now can't end the game. There's no possible universe in which you have reached the end of the game and you killed the dragon and you helped the heir elope. This has found a soft lock for us, and we didn't even have to run the game. And in fact, if you want to play at home, you can try it. You can kill the dragon and then you can help the heir elope, and then you can try and finish the game. You can't. And that is known outside of it.
Yeah, useless bit of trivia. We actually found this soft lock while we were writing this. We were like, that'd be good for the demo.
Yeah, we said we're keeping the bug. Yeah. Now, of course, this is just the graph. So the graph is not the actual game, as I've made very clear. This is just what we designed it in, and it also produces all of the lots of the logic for us, which is used as part of the game's source code, but it is not the game itself. So let's actually prove that this actually works in the real world. So. What I have here is a tool that I can run, and what this is about to do, and what you'll see on screen, is it's going to check every single part of the game to check to see if every part of the quests can be reached through some path. So I'm going to press enter. It's going to take a second to think. All right, cool. So now it is going through the entire game, playing through every possible universe, finding situations where that part of the game can be reached. Now, it will not take billions of years. It will take about a minute, and we think that's pretty cool. Now, I'm not going to stand here and fill another 40 seconds waiting for it to complete, because I don't speak that slowly, but you get the idea. This will eventually reach the end and say, yes, the entire game is now completable.
It's worth saying this actually grows linear time-wise, not exponentially. So if you have 10 times as many quests, it'll take 10 minutes, not a year. It does get slower the more you've got, obviously, but not in a bad way.
Yeah, it is O(n) times M, where N is quest nodes and M is yarn nodes. For you, because you're in the audience.
For all the big O fanatics out there. That sounded weird.
No. Okay, so back to the slides. Function F1. Hey, cool. All right. So This is not a magical piece of software. It is not a silver bullet. It has its own strengths and caveats like anything else out there. There is a very famous quote by the computer scientist Donald Knuth that came to mind while we were designing this, which is, "Beware of bugs in the above code. I've only proved it correct. I haven't tried it." The real world is messy. This is testing stuff inside the narrative domain and nothing else. This does not remove your need to actually test your game.
You have to test your game.
Please keep testing your game. But what this does let you do is it helps you target and focus your testing resources. It can tell you the paths that are necessary to see all content, for example, or to find the steps necessary to get to a specific piece of content. Or if you don't care about anything but one piece of content, you can solve for the rest of it and still have it be consistent. Each path that it can find and the constraints found along that path form the basis of a new test, which you can make part of your testing regime. And this is the first step to using this for test case generation for the QA nerds in the audience. And of course, you can use this to minimize the amount of test overlap, reducing redundancy across different kinds of tests.
Now, it can't know about non-narrative changes. So everything we're showing here, everything we're doing, it's purely in the narrative domain. And it's highly likely, unless your game is as simple as our little text game, that the players are going to be able to influence the narrative in a way that you don't control. And even the best tested, best, verified narrative game will have some way the players can muck it up.
There is a reason why, for example, most speedruns involve a person running into a corner to clip through a wall to sequence break, as opposed to finding a bug in the sequence itself.
So it means you're going to hit problems that aren't really your fault, but you still have to deal with. And what it can do, however, is it can tell you the world that you promised would exist. So you can add these constraints into your story, and then it can go, well, hang on, nothing in the narrative ensures that. So if you go, hey, no, the player will need to have the magic sword and magic armor. If you don't actually put that as a constraint in there, it might find worlds where that's not possible, and it can tell you about those, which really leads into the next point. It gives you this assumption validation. Now, when you're writing these games, you have a mental model of what you're trying to make. You know the game you want to make. You know the stories you want to tell. You know how the quests are going to work.
In other words, you have a mirror board.
The thing about this is you can now test and verify these assumptions. You can make sure that this happens. And you can catch these edge cases and trapdoor them before you actually need to get past the implementation stage of your narrative. And there's actually a really good example of this, which I find from Baldur's Gate 3, so beware, spoilers. So there's a very important quest item right near the end of the game called the Orphic Hammer, and it's entirely possible the players can throw it off a cliff. And if that happens, the literal devil goes, you idiot, you threw away the quest item, here's the quest item back, also I own your soul. Now, what that means is someone on the team either just through sheer diligence of their thought processes went, hang on, what if the player throws it off the cliff? Right, I better write an edge case handling that. Or someone in a test threw it off the cliff and then later reported back to the team, hey, I threw it off the cliff and then the game broke.
What's cool about a solver is the solver could tell you that happened before anyone even saw it.
Yeah, and I don't know which of those two approaches. Who knows? If someone knows, let me know. I'd be very intrigued to know.
I saw at least one person closing their eyes or covering their ears, so we're now leaving spoiler zone. Yep.
So essentially, the other thing this lets you do as part of your assumption validation is you can find narratively unsatisfying but valid events. So let's say, for example, your game is called I, the player, never simultaneously have 50 gold and a sword. You can actually make sure that is the case in the narrative. So it might not necessarily soft lock the game or break the game or anything, but it is narratively unsatisfying if the game doesn't prevent you from doing that.
An actual concrete example of this kind of problem is games in which you can only romance one NPC at a time. If there is some logical error that allows you to have romance two characters at the same time, and they aren't aware of each other because the game wasn't written for that, that is an example of a narratively unsatisfying but logically valid event.
And once you have this, you can sort of then verify the paths that you've got are the ones that exist. And this is another interesting one that we found while we were developing the demo game. Partway through, we were writing it, and we're testing every path through, and then it found a new path, and we're like, what the hell? What's that doing there? And it turns out John just totally forgot that he wrote in another way to learn about how to defeat Frederick. We just completely forgot that we wrote that like a couple of weeks ago, and we're like, oh wow, yeah, oops.
I like how this talk is becoming my bug parade.
Yeah, I mean, games are hard. You're going to make small mistakes.
So the key thing that we think is most interesting, in addition to being able to really just speed through your implementation and proof of your quest is save game synthesis. In other words, you can simply say, I want to be at some arbitrary point in the game, either start, at the end, anywhere in between, or some combination of constraints, and say, give me a save game. That's amazing for QA. It's amazing for in-game development. It means that you can simply jump to the right point and know that you're not testing some impossible state. You're always testing a state that the player could have gotten to. And that's huge. Because we can ask our story solver how it found any given answer and then generate the save game in any format that's required by your game, by your game engine. I mentioned earlier that this has Yarn in mind, but this will work with any kind of dialogue system as well. And we've seen a whole bunch of things like this in action. You can also do it in reverse. You can say, if I have a game state and I load it into the solver, I can then ask it, okay, given that game state, can I now reach the end? And if the answer is no, well, congratulations, now you have a situation where the player could reach a point and then be soft-locked. And yeah, you can prove that the soft lock exists. So this allows you to either prune down your collection of save games, your save game menagerie, as we like to call it, to reduce the number of tests you've got to run, or the inverse. You can generate new save games to include as part of your testing flow.
And be confident that they are going to work.
Yeah. Speaking of generating save games, Jason Imms, good friend of ours, couldn't make it this year, so we're doing story time for him this year. Back when he was a journalist, he was reviewing a very, very popular narrative game. You absolutely have heard of it, maybe even played it, and the game crashed halfway through. Oh, well, it happens, you know. And so he contacted his rep and said, hey, can you give me a new save game? I was roughly at this point in the game. And they said, yeah, no problem, we'll send you a save game. And he got one overnight. And he loaded it, completed the review, great, everyone's happy. Now, what he didn't know at the time, and what he later learned, is that what happened is the CM for the game played the game overnight to get from the start of the game to where Jason said he was, and there's okay, cool, here's your save game. Now, that actually was economically worth it because the value of a review is higher than 6 to 10 hours of expert development time. But still, come on, a person spent an entire night playing through a game, following a specific script. Yeah, come on, yeah. We should respect people's time better, and a computer can help us do that.
So this sort of all falls into what we like to think of like assisted narrative building, or you can't fuck it up at development time now, or you can fuck it up less maybe. So the idea behind this is it's actually very similar to code analysis tools. We've got linters, we've got code performance things. They can look at your code and go like, this is not going to do what you think, or this will work, but this is a bad way of doing it. It's the so-called code smell. We should be able to have narrative smell along the same sort of lines. It's really easy to add these small inconsistencies when you're building this stuff out. We ran into it in our it's a 15-minute long text adventure game. We ran into 2 bugs. We were like, those would be interesting story points to mention. And that's in something quite small. And you can actually find these bugs and quirks way earlier. You can find them when you're sitting down writing and designing the quests and writing the story, instead of finding them when you've already built out the steps for them. And like I said, we've encountered this multiple times while writing the demo game. Another interesting one we encountered was we'd accidentally split one path into 2, and we were really confused why it's going like, hey, here's a new route that I found. And we're like, why are you doing that?
I made a typo.
And it was a typo. And it wasn't a typo in a syntax error way. It was a typo in we'd made a logical inconsistency way. And the solver went, okay, I'll handle that. Don't worry about it.
Yeah. So we think this is cool. If you also think it's cool, we'd love to help you and your team. So come talk to us. This is the only ad break I'll do. We're around all week. Thank you. Thank you.
I believe we have 10 minutes for questions, was it?
Yeah, so if you have a question, please go to the mic. Yep.
Hi guys, this is fantastic. About 7 years ago now, I did a big adventure game and dealt with a lot of these problems. And I did a very, very shitty version of this that was very, very slow because it just kind of iterated through everything and said error, We've used solvers for decades now for puzzle games, especially in this industry. And what is a story if not a puzzle you have to solve? So exactly. Brilliant that you're doing this. One question, I saw in the tool, everything seemed to be flow, if true, flow-based states. Do you also support testing individual variabilization? There's an object in the world that you can optionally grab that's not tied to a story. I just add in oh yeah, cool.
Yeah. So, for example, I'll show you that right now. So, let's say that we are at, for example, the end of the game. I can also say, and I'm going to say that like we have, I can pick an arbitrary one here. Knows about the air. Knows about kidnapped air. And if I turn that on as well, like so we can combine both. Like, are we at this node, and also is this variable on at the same time? So
Great. And so, I see. Each thing, I can add a single node block somewhere and be like, yeah, I pet a dog at some point in the game.
Exactly. Or
Awesome.
I can say, for example, like if I set this back to either, if I say, all right, we're at the end of the game, but I'm also going to say that we don't know about the witch, for example, and that goes, no, there's no way you can end the game because of that.
Fantastic. Incredible work.
Thank you.
G'day, thank you for the talk.
Thank you.
I wished I had this when I started working on my RenPy game. Woo! So I have a relevant question on that. What would your tips be, best practice, if you're sort of halfway through a project and you want to start using something like this? How do you sort of work through what you already have, reverse engineer it without like chopping an arm off in the process?
So the easiest thing that I can think of is, so this tool also allows you to say, pick an arbitrary point in your story. Does a path exist that gets me to that point? So even if you're not using, for example, our tool for designing the quests, you still have a dialogue tree because that's what your game is. You can pick a point in the tree and say, is this leaf node in the tree reachable? Or is this line reachable? Or is this choice reachable?
I would also add like anything new that you can do, you can now take the approach of like, I'm going to make sure it's verified. So even if some of the earlier stuff doesn't have this sort of backing behind it, the new stuff can. And as we actually have learned from decades of like code improvement, even if you buffer, like here's the good code that I've spent time making correct, and here's the old stuff that's bad, that still results in less bugs than trying to do it all correctly and failing.
It's by no means an all or nothing approach. In fact, actually, a game that I was working on, halfway through development, I went, actually, I can use StorySolver. And so like the second half of the game uses these tools, and the first half is just as correct and interacts with it perfectly. So yeah, basically you can hop in halfway. Also, you can simply go, pick a line, can I reach that line? So yes.
All right, thank you.
You're welcome.
Hey, I'm sure you're getting compliments with every one of these questions, but what an engaging talk, what informative. I literally want to go away right now and build something with this.
Oh, thanks, man. That's very kind of you.
I have used Yarn Spinner in the past for dialogue, but I didn't know about any of this. This is really impressive. And what I'm wondering is, with the development of Yarn Spinner, I know you've been working on this for a long time. What do you think is the future for this, and or like what are the current limitations that you would want to flag if somebody were to pick up this tool?
I've got a quick answer.
Yeah.
So I think the future of things like this is this allows for more interconnected quests. This allows you to have quests that are much more tightly interwoven, that have interdependencies or optional interdependencies in a way that's narratively satisfying, but also is not so complex that you can't effectively test them and have to cut them. So I think that the future of things like this is just basically richer stories.
Yeah. I would say probably the main limitations of things like this is it's still... once you have something like this, it helps you use the resources you've got more efficiently is our goal. But it's still really easy to build something that even a tool like this can't. Like even if we were to try and get it to brute force 1.7 billion paths, it would probably take a month. Yeah. And it'll do it. It's a computer. It won't complain. But
when I was running the code that calculates the number of paths, it took 5 minutes just to count them.
Yeah. So it's sort of like it's. I think one problem with tools like this, or something you got to be wary of with tools like this, is they don't stop you creating something that even the computer can't brute force its way through. So you do have to be careful there. Like you can't, if you make something too weird and interconnected, you're still going to have to probably smash it back up into little pieces.
What this does is it raises the ceiling.
Yeah. It gives you more options.
Yeah.
Great.
Cool.
Thank you.
Hello. Thank you for the talk. This was such a really cool tech, and I wish I could have learned about this earlier this year because I've developed a choose-your-own adventure type of game that I used different engines that they have these capabilities. My question is, does this kind of thing will have a lot of applications such as figuring out when to start in line of dialogue, when you have a certain item, or when you can check off different endings in the choose your own adventure. With this kind of thing would be really cool for future applications. So that's an idea. My question is, when you're thinking about making a game, how do you use this thing to figure out the start and the end, and then have it go through all the multiple choices kind of thing?
As in, do you have to start with the quest graph first, or do you have to start, or can you start without that? Is that what your question is?
Yep, this is.
You don't have to start with the quest graph. I just found it convenient to start there because I wrote this with that in mind. But like I mentioned earlier, you can apply this kind of technique to a game that's halfway through development if you wanted to.
Something that we actively want to try and get working is you be able to build out the quest graph and then like click generate, and we'll actually have it generate yarn spinner like stub. So it'll have the structure of your quests, and then you just got to add the beauty.
Yeah.
We've handled the maths. Is something we're hoping to do.
Yeah.
Yeah, that's great. Thanks.
Thank you.
Hello.
Hi.
Hi. Just want to say, really good talk. I work in QA and a bit of narrative, so sitting through this like made a tear in my eye. Please let me know if this question is a little complex to answer, but for like a
we'll let it
We'll put in the story. Yeah.
Okay. I wanted to ask what your pre-process or quote-unquote paper prototyping looks like before you put it into Story Solver. Do you guys tend to write scripts to completion and then simplify the story beats and then put them into Story Solver, or do you just kind of like...
We found that like laying out the overall structure of the quest in the graph first is just a good way for us to think about it, but we don't think that it's required. The way we do it is we start with the graph because my head's been in graphs for a long time now. But also I know, for example, a friend of ours who wrote a demo game for us just sat down and just banged the whole thing out in 3 days in script, and now we're coming back and going, is this valid? And turns out yes. So yeah, the way that we do it is one way, but it's not the only way. Yeah.
Thank you.
Thanks.
Hi. Oh,
Hi. Yep.
I need to move closer. Thank you as well for the talk. I'm also a QA tester working alongside Sophia, who was just speaking. Awesome tool.
Thank you.
Thank you.
My question is similar to others. Say for you have pre-existing work and you're using perhaps a similar tool, but you want to jump over to Yarn Spinner. Does Yarn Spinner have the capability for importing files that would save us having to rewrite
Not
portions
built in,
of
but we could
our-
write one.
At the moment, no.
Yeah. At the moment right now, not one you can download today.
Yeah.
But
Okay.
like a dialogue tree is a dialogue tree. They're pretty convertible. So like there's going to be some cases where like some things are just not expressible in Yarn Spinner, but I can't really think of what those might be right now.
So like a joke talk title that we were working on, which was going to be called "Removing the Beauty from Your Art," was like what we were thinking about calling this. It's like it always sounds cruel when you're like, I'm just going to get rid of all that beautiful writing. I'm just going to make it about cold, hard,
Facts.
control flow graphs. It's all facts.
Boolean
it's all
satisfiability.
Boolean.
Yeah.
Like, we're going to get
kill
rid
the
of
darlings.
it. But,
Yeah. Kill the darlings. Now there's no darlings left.
yeah. Now we can prove they're good. Then we can jam the darlings back in.
But yes, to actually go back to what your question was, is it possible to go from like some existing thing into Yarn Spinner? Yes, with a bit of support from us right now. So happy to chat. But also, they're not incompatible. So probably yes.
Beautiful. If it helps, I'm thinking of tools such as like Artisy and
Yep.
Twine, those kind of tools.
Yes, yeah, that's what we have in mind as well when we think about other tools. Yeah.
Beautiful.
Cool. I think we've got
Thank
time
you.
for one more.
Yeah.
That's it. So you might get to be lucky last.
Yeah.
Thank you very
sorry.
much. Excellent talk.
Thank you.
When you described finding the soft lock in your demonstration, you found that by accident.
Yep.
Have you investigated tools for finding, does this script have a soft lock through automation without brute force?
Yes. So one of the ways, we haven't run it on this particular game here, but I have run it on previous games, where basically you identify, okay, my end state is, for example, defeat the evil prince. And then you just repeatedly check every other combination of other game states. So are we at the game and the dragon is dead? Are we at the game, at the end of the game and the dragon is dead and another quest? And so you just go through every permutation of, we're at the end of the game and the rest of the quest states are this.
Yeah, so like if you think back to like that tree structure where we showed how the solver brute forces solutions, what you can do is once it finds a solution, you can be like, but not that one. And then have it recalculate and keep going. You just keep going, no, but not that one, until eventually it runs out of but not that ones to do.
So for example,
can be done automatically.
if I run the checker on here saying, okay, can we get to the end of the game, and I want to assume that the dragon is dead and that we have. Like the dragon is dead, we help the heirlope, and like yes, we can find a way to stop him, but if we go much further here, it's going to take a second to think. Can we defeat evil Prince Frederick? Spin, 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 spin. Wait for it. Oh, big tense moment. Yay! Yeah.
So the cool thing is you can never know how long this will take.
Yeah, it's actually, but as in mathematically you can't know how long it will take. It's actually been proven to not be, well, unless NP equals P, but that's a different thing.
Yeah.
But yes, basically you could find, basically, depending on the length of your game, it will take probably about 10 minutes, I think, to exhaustively find every possible soft lock in the game for this.
Right.
Yeah.
Thank you very much.
Yeah. Cool. I think that's all the time we have for questions.
We're here all week.
We're here all week. Find us in the corridors. Find us on Meet to Match. Enjoy your GCAP. Bye.